All right, let's talk about something we all use every single second, but probably never actually see. It's the invisible backbone of our super connected world, microwave technology. From the phone in your hand to the satellites way up in orbit, these waves are the real unsung heroes of modern communication. So let's pull back the curtain and see how this amazing stuff actually works. Here's our game plan. First, we'll get a sense of the incredible scale of this invisible network. Then, we'll dive into the basics. Microwave 101. We'll look at why it's so dominant in telecom, tackle the real-world challenges engineers have to solve, and finally, see how it's getting a major upgrade to power our 5G future. Okay, first up, let's try to wrap our heads around just how massive and absolutely essential this invisible network really is. I mean, we've all been there, right? You're driving through a rural area, maybe you're up in the mountains, miles from the nearest city, and you still have bars. How does that even work? There are no cables running up the mountainside. Well, the answer is often flying through the air. And this is where the scale just gets mind-blowing. Let's take India as an example. Over 500,000 mobile towers there are connected not by physical fiber optic cables, but by these microwave links. Just think about that. It's a vast, invisible highway crisscrossing the sky, carrying our calls, our texts, our videos, across places where laying a physical cable would be a total nightmare. So, how does this invisible highway actually function? Let's break down the fundamentals of what these waves are and what makes them tick. So, what is a microwave really? At its core, it's just a type of electromagnetic wave. They sit in a very specific frequency range, from about 1 gigahertz all the way up to 300 gigahertz. And like all electromagnetic waves, they travel at the speed of light. Now, this is what's really cool. If you look at the whole electromagnetic spectrum, microwaves are in this perfect sweet spot. They're nestled right between the lower frequency radio waves and the higher frequency infrared light. And this position, it gives them the best of both worlds. They can carry a ton of data, way more than radio waves, but they can still travel long distances pretty effectively. Okay, now we get to the single most important rule in the world of microwave communication. You gotta remember this one: line of sight. The signal has to have a completely clear, direct, and unobstructed path from the transmitter to the receiver. No big buildings, no mountains, not even a dense forest in the way. This one rule dictates absolutely everything about how these networks are built. So how does a link actually work? Well, it's a really simple and elegant process. First, your data, your voice, your video, gets converted into a microwave signal. Then, a dish-shaped antenna, a parabolic antenna, focuses all that energy into a super tight, narrow beam, kind of like a laser. Finally, on the other end, another dish catches that beam and converts it right back into data. That's it. So if you need this perfectly clear line of sight, you might be wondering, why is this technology so popular? Why not just use fiber everywhere? Well, it turns out microwaves have some killer advantages. And those advantages are huge. For one, they can handle a ton of bandwidth, which is exactly what we need for streaming and everything else. Two, they are way more cost-effective. Just think about it. No need to spend millions digging trenches across the countryside for fiber. That leads right to the third point. You can deploy them fast. A link can be set up in a matter of days, not months. And finally, they're super flexible. Got a river, a canyon, a mountain? No problem. You just beam the signal right over it. But of course, it's not all easy. I mean, we're talking about shooting a precise beam of energy through the air over long distances. Engineers have to deal with some pretty significant real-world hurdles. Yeah, path planning is a true art form. It's not just about drawing a straight line on a map. Engineers have to make sure this football-shaped area around the beam, called the Fresnel zone, is mostly clear of obstacles. They have to calculate the exact tower height needed to get over trees and buildings. And get this, for really long links, like over 15 kilometers, they literally have to account for the curvature of the Earth. The first big enemy is weather, especially heavy rain. You can think of a rainstorm as a giant sponge in the sky that just soaks up microwave energy. The water droplets absorb and scatter the signal, making it weaker. It's a problem called rain fade. To beat it, engineers have to build an extra power, like a turbo boost, to punch that signal through the storm. And the second major challenge is interference. Imagine a crowded city with thousands of these microwave links all firing at once. If their signals are on similar frequencies and their paths cross, they can clash and scramble each other's data. It's like trying to have a conversation in a room where everyone is shouting. It takes some seriously careful planning to keep those invisible highways from crashing into each other. So, with all these challenges, you might think, okay, this tech sounds kind of old. Isn't fiber optics just going to replace it? Well, here's the twist. Microwave isn't going away. It's actually evolving in a huge way to help power the next generation of wireless. And this visual really says it all, doesn't it? The amount of data that 5G networks need to handle is just on another planet compared to 4G. It's not a small step up, it's a colossal leap. And that means the backhaul, the connection from the cell tower back to the main network, has to be an absolute monster. So, how do you do it? The solution is to move to a new neighborhood on the spectrum. Meet the E-band. These are ultra-high frequency microwaves, way up above 70 gigahertz. Think of them less as a highway and more as a multi-lane, multi-gigabit superhighway for data. They can carry so much information that they're the perfect wireless alternative to fiber for connecting all those new 5G cell sites. So the next time you make a call, stream a movie, or get that instant connection, just take a second. You might not be using a wire at all. Your data could be soaring across that incredible, invisible highway in the sky, proving that even after all these years, microwave technology is still one of the most vital pieces of our modern world.